Round each decimal to the nearest hundredth. Remember, that means to keep 2 decimal spots. So we look at the 3rd decimal spot here to tell us whether to round up or to keep the decimal as it was. If it is 5 or more, we raise the value. So here, since this 9 is more than 5, we need to change it from 39 to 0.40. Which data distribution has natural variability? The lengths of students' right feet or the widths of students' math books? Explain. There are 2 different types of variability. One called natural variability and another called measurement variability. With natural variability, it's variability that occurs due to differences in people or objects' characteristics. For example, people have different heights, or rocks have different weights, or cats have different fur colors. The other one, called measurement variability, is variability that occurs due to errors in how we measure or collect data values. For example, when we're measuring distances, we might hold our measuring tape in a different place, or might estimate that it's slightly above or below, depending on where our measurement takes place. So in this case, natural variability is when the characteristics of something is different. So our feet are different sizes. All of our math books should be pretty much the same width. So that would be measurement variability. Number 2. Students in Mrs. Chan's class measured the lengths of their left thumbs. First, 8 students measured their left thumbs. Then 1 student measured all 8 thumbs again. Which data distribution do you think has more measurement variability? Explain your reasoning. Well, the distribution for the measurement where the 8 students took their own measurements will likely have more variability because they may measure in different ways than if 1 student does all of the measurements. Two groups of 21 children sign up to attend a summer camp during 2 different weeks. The camp counselors record the ages of the children in each group. In the group for week 1, the minimum age is 5 years old and the maximum age is 11 years. In the group for week 2, the minimum age is 10 years and the maximum age is 16 years. Let's think about the ranges for these distributions. For week 1, we went from 5 to 11, which is a range of 6. In week 2, we went from 16 to 10, which is also a range of 6. Range is just one way that we can measure variability. Some other ways that we measure variability is the interquartile range or the mean absolute deviation. Here we see some additional information. It says the mean, or the average age in week 1 was 8 years, and the average age in week 2 is 13.2 years. The mean absolute deviation here was 1.2 years, meaning typically the campers were 1.2 years away from this mean, and in this one they were 2.1 years away from that mean. Based on this data, week 2 has more variability because 2.1 is bigger than 1.2. The interquartile range tells us the spread of the middle 50% of the group. So in this one, the interquartile range was 2 years, and in this one, it was 4.5. This also indicates that week 2 has more variability because 4.5 is greater than 2. This tells us that the middle 50% of the campers had a spread of 4.5 years, and the middle 50% of campers in week 1 had a spread of only 2 years. Based on the dot plots, how does the variability of ages in week 1 compare to the variability of ages in week 2? Why? Well, the ages in week 1 have less variability than in week 2, which we saw from the interquartile range and from the IQR, which was lower or less for week 1 and greater in week 2, meaning it has more variability, and this one has less. And the way we see that is because the majority of the points are clustered or grouped around the mean and median. However, in week 2, most ages are clustered near the minimums and maximum values. The range tells us the difference between the minimum and the maximum, but it isn't always the best way to measure variability. Number 3 in your workbook says, children at a summer camp choose a daily activity. The histograms summarize the ages of children who choose certain activities on Monday. Find the range, mean, and mean absolute deviation for your assigned histogram. Well, let's look at the ranges for each of these. If it's 5, it's going to go in here, but if it's 6, it gets bumped into the next one. If it's 11, it goes in here, but if it's 12, it gets bumped into the next one. So this one has a range from 5 to 11. Which is a range of 6. This one goes from 5 to 11 also, which is a range of 6, and for the last one as well. Then we need to find the mean. For the mean, you're going to add up the data values and divide by how many there are. There are 3 5s and 3 6s, 3 7s, 3 8s, 3 9s, 3 10s, and 3 11s. That has a sum of 168 And there are 3, 6, 9, 12, 15, 18, 21 data values because each of them has 3. So 3, 6, 9, 12, 15, 18, 21. When we divide, we get a mean of 8. Let's do the same type of thing for the other two. Here I have 1 5, 2 6s, 4 7s, 7 8s, 4 9s, 2 10s, and 1 11. Oops. Add all those together. That is also 168. And there's 1 in here, 2 in here, 4 here, 7, 4, 2, and 1. If we add all those together to figure out how many data values there are, that'd be 3, 7, 14. 14 plus 4 is 18, 19, 20, 21, which is also a mean of 8. For this last one, there are 5 5s, there are 3 6s, 2 7s, 1 8, 2 9s, 3 10s, and 5 11s. Add all those together and then divide by, let's see, that's 5, 3, 2, 1. That'd be 8, 9, 10, 11, 12, 13. 13 plus 3 is 16, plus 5 is 21. So you're going to divide your total by 21. Which is also a mean of 8. To find the mean absolute deviations, we need to determine how far away the data values are from 8. To get from 5 to 8, that is a difference of 3. So we need to write down 3, 3, 3. From 6 to 8, that is a difference of 2. From 7 to 8, that's a difference of 1. From 8 to 8, that's a difference of 0. To get from 9 to 8, that's 1 away. From 10 to 8 is 2 away. And from 11 to 8, that is 3 away. Now we need to add all those up and divide by 21. That sum is 36. So the mean absolute deviation would be 36 divided by 21, which rounds to 1.71. For here, to get from 8 to 5, that's a difference of 3. 6 and 8 are 2 away from each other. 7 and 8 are 1 away. and there are 4 of those. 8 and 8 are 0 away. 9 and 8 are 1 apart. 10 and 8 are 2 apart. And 11 and 8 are 3 apart. Add all of those, then divide by 21. That has a sum of 22. So for the mean absolute deviation of this one, 22 divided by the 21 values is approximately 1.05. Now let's look at the last one here. 5 to 8, that's a difference of 3, and there's 1, 2, 3, 4, 5 of them. Six to get to 8 is 2 away, and there are 3. From 7 to 8 is 1 away, and there are 2 of those. From 8 to 8, that's a difference of 0. From 9 to 8, that is 1 away. From 10 to 8 is 2 away. And from 11 to 8, that is a difference of 3. And there's 1, 2, 3, 4, 5 11s. Add all of those values together and divide by 21. The sum of all of those should come out to 46. Then 46 divided by 21, when rounded, is 2.19. Number 4 says which distribution has the least variability. To measure variability, we look at the mean absolute deviations. So 1.71, 1.05, or 2.19. The lowest of those 3 is this canoeing. It had the lowest mean absolute deviation. Which distribution had the most? That was the reading buddies, which had the highest mean absolute deviation. That is the end of lesson 21. We should have one more video to wrap up module 6.